looking at our first page, at the end it says to check with the calculator. We don't have time for that. So let's go on and do the problems and be done with. So on number 1, so 2.7 basically is simplifying derivative. So what we did last time was we found the derivative, we kept it in a long form, and we were done. Okay? Today we're going to simplify them, meaning double distribute and so on, combine like terms, factor out, and be done. Okay? So for number 1, which derivative are we looking for on number 1?
2.
The second derivative. So then just by looking at this, are we looking at product rule or quotient rule? Quotient. So let's do a quick reminder. This could be a natural review for our test as well today. So on our quotient rule, what do I do at the bottom? Square it. And unlike the product rule, the quotient rule has what sign separated? Minus. So the rule says derive the top, which is what? 2. And we keep the bottom. Minus, we keep the top. And when I derive the bottom, what do I get?
1.
The 1. And let's go one more step and actually simplify them. And by simplifying, I mean distribute the 2, multiply out 2 and the 1 with a negative. So let's write out, we have 2x plus 10. This is more of algebra 1. So in case you were missing algebra 1, here we go. And for the bottom, I think I want to just leave it as it is until we simplify everything on the top. So then do I have a 0 pair that I can cross off on my numerator? Yep, that's going to go away. So when I do simplify this, it's going to look like the following for the first derivative. 10 all over x plus 5 all squared. So that's part 1, but it's not asking us for part 1, so if you don't want to box it, that's fine. Now here's what I would do for this piece to make my life not miserable. Let's rewrite this so that I have this in a product formation. Because when I write it with a negative 2 on the power, all I need to use is a power rule. So then for my second derivative, what do I do with my power and my coefficient? Multiply them, so I get negative 20. And then we keep the inside, kind of like the chain rule. What is 1 less of negative 2? Negative 3. When I take the derivative of the inside, isn't that basically 1? I don't want to write that piece. So then our actual final answer for this one, because having a negative power is considered improper, we are going to bring it to the bottom, and that is our second derivative. So before we made it pretty messy like this. Now we're able to combine like terms and cross things out and make it neat into single formation. Yes, ma'am?
But I thought like if you multiply like the negative 2 and 20,
Mm-hmm.
wouldn't that just be like the chain rule where then you do times 1?
Yeah, but I don't want to do the times 1. Okay? All right, let's go on to number 2. So on number 2, the first thing we should do is rewrite this. Because if you have a square in between the cosine and the argument, it's considered all squared. So let's rewrite this. Cosine of 3x, all squared. Then that way you see a chain rule. So for this piece, hopefully I have enough room. I'm going to try to squish it down here. So let me do this. You guys might have enough room though. So we have y prime. So we have chain rule again. When I take my 2 and bring it down, it's just going to be 2 since there's not another coefficient. Am I going to mess with the cosine at the moment? No, leave that alone. And the inside. And 1 less of that 2 is how many? If you want to write 1, go for it. If you don't want to, you don't have to. So then we're going to go in the inside. What is a derivative of cosine? Negative sign. And of the inside of that one, we're not going to mess with. So now, when I derive the very, very inside, what is a derivative of 3x? 3. Here's all that I want when I give you a question like this. You take the coefficient, which is a number by itself, the 3, which is all by itself, and go ahead and multiply them. And while we're at it, isn't that also considered a number by itself if you think of a 1? So let's write out 2, the negative 1 and 3. When I multiply, we get negative 6. Then I have cosine of 3x times sine of 3x And that will be our simplified first derivative. So if it's inside the parentheses right after your trig function, don't mess with it. That's already a function within. All right, for number 3, we have a product rule. Let's go ahead and put this in parentheses, because I like parentheses. All right, for the product rule, we derive the first one. What is the derivative of the first component? 20x to the third. And then do I mess with the second one? I'm just going to leave that alone, as I have. If you want to use parentheses, go for it. And then the next one, we have plus. We keep the first one. And when I derive the next one, because the negative is going to be involved, I'm going to put parentheses to say it's not a minus sign. Let's kind of recall. What is the derivative of cosecant? Cotangent. Very good. If you knew this, go ahead and give yourself a tap in the back. Very good. So all the derivatives with the co has a negative in front. Okay? All right. So at this point, let's see how we can combine like terms. Not combine like terms. How we can factor out GCF. So go ahead and make a little two different markings separated by a plus sign. And I want to look at one component at a time. So watch where I'm pointing at. 20 and 5. What's my GCF of 20 and 5? 5. Take it out. X cubed and x to the 4th, which is my GCF? X cubed. And then looking at our trig function, what is common between these two that I could take out? Cosecant. Now open your parentheses, and everyone that is remaining is going to go inside the parentheses. So let's compare. I already have x cubed. I already have cosecant x, but I don't have 20. But what is 20 divided by 5? 4. And because of that minus, I'm going to go ahead and separate it by a minus sign. The 5 I already took out. I only took out 3 x's. So how many do I have remaining? 1x. From the trig function, since I took out the cosecant, what is remaining after that? Cotangent of x. And that is our final answer. So yes, go ahead and combine what you can, factor it out, write the remaining, and we're done. So really, in the end, if your long derivative became a little bit shorter, most likely you're done. Okay? Okay, now let's go on to number 4. On number 4, let's see if I can do something like this. Do I see a product rule again? Yep. Since I already have parentheses within it, I'm just going to go ahead and circle it. That's just my way of notating. If you have a different way, go for it as well. All right. To find the derivative, since I know it's the product rule, I am going to go all the way over to this room over here, y prime. Since I'm going to write pretty big. So my derivative of the first one, isn't that already a chain rule? So 2x plus 2. And I know when I take 1 less of the 2, it's 1. You can write the 1 on the power if you want. I don't want to. We keep the second one. What sign is going to be separating our product rule? Should it be cubed? Yeah, it should be cubed. Who was that?
Hannah.
Hannah or Taylor?
Taylor.
Got it. So what sign should be separated by after that?
Plus.
Plus, very good. And then do I derive the first one or keep the first one after this one? Keep. So I have x plus 2 all squared. And when I derive the second one, isn't that another chain rule? So 3 comes down. We keep the inside. It is 1 less, which is squared. What is the derivative of the inside now? 2. So let's see how we can actually factor things out. And I'm going to use this color. And if you were in your pre-calc class with me last year, we did something like this at the beginning of the year. And if it's been a while, that's okay. Luke, question?
Why did you do the chain rule for the second one but not the first one?
I did do the chain rule on the first part, and then chain rule on the second part. Here, if that makes you happy, here's a 1. And the derivative of the inside is just 1.
Oh, I meant the x plus 2. Wait, yeah, no, never mind.
Never mind. Got it. Got it. All right. Now let's look at the whole numbers. Here's a 2. Here's a 3 and a 2. What is common between those two? 2. So let's take that out. So here's my 2. How many x plus 2's can I take out concurrently? Just one of them. How many 2x minus 3's can I take out at the same time? There's a 3 over here, and there's 2. 2 of them. It's always a lesser of the 2. And let's put them back. So compare with me. I see a 2. I see x plus 2. I don't see 3 of the 2x minus 3, so I need to put that one back. And I'm going to take it out of the parentheses because I know at some point I need to combine like terms, so might as well.
Wait, why did you put it? 2x minus 3. Oh, because
There's 3 of them, and there's only 2 that I took out. Okay, the next one. I know I took out the 2, but I did not take out the 3. Leave that alone. What about the x plus 2's? Did I take them all out or one less? One less. So I need to put one more back inside. And notice I put that in parentheses because 3 was a coefficient that is going to eventually be distributed. How about 2x minus 3's? Are we satisfied with that one?
Yes.
Yep. So the only thing we need at this point is simplifying the inside. So to avoid myself writing too much, I'm going to just write out 3x plus 6. And then let's combine like terms. So let's start by copying this beginning. 2x plus 2, 2x minus 3 all squared. And then, how many x's am I going to eventually have when I combine like terms? 2x and 3x? 5x? What about my constant? Plus 3? And I can't go any further. That's it.
I'm confused on how you got that. You would do 5x.
I did 2x plus 3x, negative 3 plus 6. You could write the in-between steps, but I knew writing all that could be too much. All right, our last one. Again, really good practice for the test today. Let's do our implicit differentiation. And let's go ahead and derive this. And I think I want to put my white out so the 5 is not part of it. Okay, let's derive with respect to x. Are we deriving it once or twice? Once. So here we go. What is the derivative of negative y cubed? Negative 3y squared. And because it's not an x, we have to put in dy over dx. The next piece, let's go ahead and write this as a product form right above it so our brain doesn't get confused. So our product rule says we derive the first one. What is the derivative of x squared? 2x. And then we keep the second one, y squared, plus I keep the first one and we derive the second one, which is 2y. And don't forget dy over dx. And then my next component, what is the derivative of x cubed? 3x squared. And then my next one says 2x to the power of 4. How many is that? 8x cubed. And the derivative of any constant is how many? 0. So I'm going to do two things at the same time. I am going to subtract this one, subtract this, subtract this. And at some point, I am going to divide. So I'm going to leave it as a division long fraction. So we have minus 2xy squared, minus 3x squared, minus x cubed, 3x cubed, or 8x cubed. And then we are going to divide it by the value in front of dy over dx. Negative 3y squared plus x squared times 2y.
Wait,
What's up?
why didn't you subtract the x squared?
X squared. Where are
The
we?
second circled one where it's like 2x, x squared times 2y.
They're side by side. They're all being multiplied together.
Oh,
Okay? All right. So let's kind of talk about what we can factor out. What variable is common on my numerator? X. If you see 2, you're not looking at 3 as well, right? So just the x. So negative 2y squared minus 3x, since we took out one of them, minus 8x squared. On the bottom, what variable is common that I could take out? That is separated by a minus sign. I see a common variable y. So I have negative 3y plus 2x squared. And that's going to be our final answer. Now, I want to talk about something that is common in the AP test. Students will typically get this correct, no problem. And then the AP test is going to turn around and give you the following answer. So write this out. Not going to say it out loud, just write out what's on the board. So we can discuss why they are the same. And this happened to one student on one of our pop quizzes at one point in time. And that's why I gave them full credit. So let's kind of do a compare and contrast. The X and Y at the beginning, did that change at all? Look at the inside. What happened to everybody in the inside compared to the beginning and the end? They're all opposite. Look at the bottom. Are they also opposite? So what's happening really in the end is this problem is being multiplied by a clever form of 1. When I multiply -1 by -1, don't I get this value in the end? What is -1 over -1? If I multiply anyone by a 1, did I really change the value? No. So if you get to the AP test and you get an answer like that, and then you go, well, I don't see the choice on there as my correct answer, multiply the top and the bottom by a -1, and it'll be the right answer on your answer choice. All set? All right.